Hello and welcome to Physics Problem 1 by 1. Today is Mechanics, Kinematics. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Okay, part 2 of the same problem. So, last time, in the previous video, we arrived with two different average speeds. This formula and this formula. One for the case when the body was traveling the same time with the speed v1 and then with the speed v2, and another permutation when the body was traveling the distance, same distance, with speed v1 and speed v2, and we received this formula. And if you recall, with numbers 40 and 60, we received 50 kilometers an hour in that case, and 48. And this kind of raises a question that this number is smaller than this. And if we observe this, the next question would be, is it by accident? Or maybe it's always the case. Why don't we put like 30 and 70? 30 plus 70, it still will be 50. Here 30 plus 70, 100, 2, 3, 7, 3 by 7 would be 21, so 42. 42 would be average speed. So it's even more discrepancy between 50, which is unchanged, and 42. Let's put 20 and 80. 20 and 80 would be 50 here, and here it would be 20, 80, 16, 32, if I'm not mistaken. So we kind of see the pattern. Let's try to prove it. Let's try to prove that this number is always less than this number. So what we're trying to prove is this number 2v1, v2 divided over this is, and I want to put this number, but I don't know yet. So I kind of tilt this sign, tilt it down, and this kind of indicates that I don't know for sure that this would be the case. But anyway, that's what I'm trying to prove. Notice that they're all positive numbers. When we're dealing with equations and when we're multiplying on negative number, we will have to change the sign. Here everything is positive, so we can multiply, no problem. So we multiply this here and this here, so there is no fractions. No denominators. This would be much, much easier for us. And this is a plus b squared, the famous formula. And we can, of course, expand it, and we will receive this. And of course, if we look, we see that this and this is kind of very similar. So we moved this from here to there. And we're of course not forgetting to change the sign. So plus 2 minus, it becomes minus 2, v1, v2. Because we also see that this is a minus b squared, this is a plus b squared. We can see that this is v1 minus v2 squared. And of course we know that this is a square, so it's always bigger than 0, so we change this here to greater, and we change this everywhere going up backwards. And I said greater than 0, but of course if this is 0, then it will be greater or equal. So this is a possibility when this v1 equals v2, then it's all the same. If v1 and v2 are the same, obviously it would be the same result. If v1 and v2 are the same, it would be the same results. And it's very easy to to observe this. If V1 and V2 is the same, let's say V. So this will become 2V over V, and this will become V. Of course, we can put V1 here over 2, and this would be V1. We don't have to take VV2 and V1, let's put it V1. And likewise here, we put 2V1 squared, and this would be 2V1, and this will be gone, and this would be V1. V1 and V2, they're absolutely the same, and it's kind of obvious thing. When both speeds are the same, the body moves with a constant speed. And when the body moves with a constant speed, it moves the first half with the speed and the second part with the same speed. And of course, average is the same, because speed is the same and it's only dream, not in the traffic. Or maybe when you fly an aircraft, or maybe when you fly in the space, then speed is always the same. But anyway, this mathematical thing proves that this average is always less than this average. Okay? This is mathematical proof. Let's look on this from the physical point of view. Maybe we can obtain the same results. Let's talk a little bit about graphs. So, let's graph the first scenario, when we have time, and when we have speed, and when we have this time and 2t. And then this is when we're moving with the speed v1, and this is when we're moving with the speed v2. So, we're moving with this, and of course average, this is the total, this is the distance covered for the first time t, and this is the distance covered for this part. And of course, if we draw this average here, then obviously, and let me take maybe another color, I don't know if it will work, but this would be, no, it's pretty much the same color. But anyway, this rectangular will have the same surface as this area. And that's why this is straight between. And this is the first scenario. And let's look on the second scenario. And second scenario, let's imagine, remember when we have the distance, half of the distance, and when we are moving with v1, and let's imagine that v1 is extremely small. I don't know, v2, let it be 60 kilometers, and v1, what would be 1 kilometer. So, with 1 kilometer, to cover the same distance as we cover with 60 kilometers, it will take us 60 times time. So, if 60 times more time would be required. So, if this is very small, this would go, I don't know, very far. And then there would be a spike with a very big speed and very short in time. And this surface should be equal to this surface because we have the same distance. Now notice these surfaces, this one and this one, they are different because we're traveling with different speed, but we're traveling same amount of time. Here we cover the same distance, but with different speed, and it means that if the speed v1 is very small, this d over v1 is extremely small, and then when we will calculate average as 2d divided over this dv1 plus dv2, this would be very, very big, denominator would get very, very big. So in extreme case, when one of the speeds is very small, this average speed will degrade significantly. Another way how to look on this extreme case scenario is just to look on those formulas and say what happens if V1 equals 0. This is typical physical, the way the physicists will discuss the formula and the situation. Extreme case scenario. What if V1 would be 0? V1 equals 0. V average would be V2 divided in 2, because V1 is gone and it's V2. And if we put the graph here would be like this. For some period of time the speed would be 0, and then the speed would be this, and it would be the whole distance. So no distance is covered when the speed is equal 0. And what will happen here? In this case, well, V1 equals 0 and it will be 0. So if V1 equals 0, V average would be 0. So it's extreme case scenario, and what would be with the graph? The graph would be like this. This is time, time, velocity, velocity. We will be standing forever, because moving with 0 speed we still have to cover half of the distance, but we will never cover this half of the distance. Anyone who spent time in traffic knows this. So this time becomes forever, infinite. And so that's why those different approaches, they show you the same result, that this thing is always less than this, less or equal. Of course it's equal if the speeds are the same, but it's not an interesting case. So that concludes part 2 of this problem, and you see that if we go a little bit deeper, there is no end, and that's how physics is organized actually. Anyway, don't forget to click subscribe, don't forget to click like, and this way you will not miss on the excitement of my new problems as I will publish them. Thank you very much.